Alright, so this is the start of Chapter 5. This is 5.1 Fundamental Identities. I'm going to go through this fairly quickly, but each time I'm going to be referring back to your identity sheet. So you definitely need your identity sheet out for this lesson. Alright, so we're going to start off with the basic trig identities. You should find these at the top middle part of your paper, and all of these should be reviewed from Chapter 4. There's none of these that we didn't talk about in Chapter 4, so just remember those. You should have known those for your test. What is new, or at least the start of what's new, are these three. These are our Pythagorean identities. These are still in the middle, but a little bit further down. Alright, these you really need to know, and we're going to use them in just a second. Know that your Pythagorean identities ultimately come from the Pythagorean theorem. So cosine squared plus sine squared equals 1. Well, if I do a triangle on my unit circle, this is cosine is my x, my sine is my y, and then 1 is our hypotenuse because it's the radius of our unit circle. So this is just a squared plus b squared equals c squared, and then the other two are just derivations from that. Alright, so we're going to use those two identities. And we're going to try to do problem number 1. Okay, it tells me to find sine and cosine. It says tangent of theta equals negative 4/5. It also tells me that sine of theta is greater than 0. Well, things that are greater than 0 are positive. So sine is positive. Well, remember that tangent is sine of theta over cosine of theta. And it tells me right here that tangent is negative. Well, if tangent's negative, that means sine or cosine is negative and the other's positive, because the only way I can divide two things and get a negative is if my signs are different. Well, if I know that sine is positive, that means that cosine, so there's my fraction bar, has to be negative. That's the only way I can get tangent to be negative. So I'm going to say cosine of theta is less than 0. Okay? It's negative. Alright. I have tangent, excuse me, and it asks for sine and cosecant. So looking at my identities, go back a page. Tangent gives me secant, but they don't ask me for secant. They ask me for sine and cosecant, and secant, the reciprocal of secant is cosine, which they also don't ask me for. But I know that the reciprocal of tangent is cotangent, so I'm going to use, I can figure that out pretty quickly, and then this right here is one of the things they asked me for. So we're going to use this one. So I'm going to say 1 plus cotangent squared equals cosecant squared theta. So this is the identity I'm going to use. I'm going to substitute what I know. I know that cotangent is the reciprocal of tangent. So this is going to be negative 5/4 squared. Okay. Well, when I square a negative, it becomes positive. When I square 5, it becomes 25. When I square 4, I get 16 cosecant squared theta. I need to change my 1 to 16/16 so I can combine my fractions. If I combine those together, I end up with 41/16 equals cosecant squared theta. Well, I want to find out what cosecant is, so I just need to take the square root. Square root, square root. Whenever I take a square root, I put plus or minus in front. But we're going to actually figure out which one it is. Is it plus or is it minus? Well, up here, we know that sine is positive, and cosecant is just the reciprocal of sine. Well, when I do the reciprocal, I don't change the sign, so the reciprocal has to be the same sign. So if sine's positive, cosecant also has to be positive. So I'm going to have cosecant of theta equals, I'll put the positive sign there even though we really don't need it, positive square root of 41, because it's just the square root of 41, can't do a whole lot with that, over, well, the square root of 16 is 4. And I have cosecant is that. That's one of the two things it asked me for. Sine of theta is just going to be the reciprocal of that. It's going to be positive 4 over square root of 41. But of course, they're not going to let me keep a square root in the denominator, so I'm going to multiply top and bottom by square root of 41. And that will give me sine theta equals 4 square root of 41 over 41. Both positive. All right. Our next set of identities is the last set we'll have for this lesson, are our cofunction identities and our odd-even identities. All right, cofunction identities basically just say that if I shift my function by pi over 2, then I can end up with a different function. And my odd-even identities tell me that for almost all of my identities, if I change the angle to being negative, so let's say I find sine of negative 60 as opposed to positive 60, the only difference is it changes the sign of my final answer. The only exceptions, the only ones that are different, are these two. These are even, so the others are odd, these are even. And they're even because it says that if I put a negative in here, it doesn't affect the final one at all. So cosine of negative 60 degrees is exactly the same as cosine of positive 60 degrees. The sign of what's the angle does not affect the final answer. All right. So we're going to use a combination of all of these identities as we move forward. Let's look at number 5. Start with this one. So I look at this one and I'm really tempted to say, oh yep, that's one of my identities, but it's not. So look at this one. It says secant of theta minus pi over 2. My identity says secant, it's right here, secant of pi over 2 minus theta. Well, that's different because it's subtraction. If it was addition, it would be the same, but it's subtraction, so it's different. So I need to switch those around. I'm going to say this is secant of negative pi over 2 plus theta, and that's still different, so I'm going to say this is secant of, we'll factor a negative out, pi over 2 minus theta. Okay, so now at least I have the pi over 2 minus theta, but I have this negative out front. Well, we had an identity that said that secant of negative theta is just the same thing, I left out of secant theta. So the fact that I have a negative there doesn't affect the final answer. I can essentially just get rid of it, I can cancel it out, because it's not going to change what secant is. If this was tangent or sine or cosecant or cotangent, I would have to take that negative and move it out front. Essentially, it would make the entire thing negative. So I can now rewrite this as secant of pi over 2 minus theta. And then once I say secant of pi over 2 minus theta, I can say that, oh, well, this is the same thing as what? Oh, no, actually, I'm going to leave this right here. Yeah, so secant of pi over 2 minus theta is the same thing as cosecant. So this is the same thing as cosecant theta. Well, up here it tells me that cosecant theta is 1.13. So I'm going to substitute and say, well, secant of pi over 2 minus theta equals 1.13. And they asked me to find secant of theta minus pi over 2. Well, I changed this, so now I could write, well, all of these are equivalent. So now I could write secant of pi minus, or theta minus pi over 2 equals 1.13. So I should have circled that one instead of that one. Sorry. There we go. For this section, I'll go ahead and tell you that each one is either going to be this value right here, or it's going to have a negative sign. So the answer is going to be that value. It just might change signs, so just be on the lookout for that. So this is more about, can you show your steps in getting the number rather than can you figure out what it is. Okay. All right, we're going to skip ahead and look at number 9. Alright, notice that there is no equal sign here, so we're not solving anything. We're just simply changing the form. Alright, trying to simplify. Well, cotangent, if I remember, I have an identity that says cotangent theta is 1 over tangent theta. That was one of our first identities we looked at. So I'm going to make that change. If I make that change, well, whenever I multiply something, in this case tangent, by its reciprocal, they cancel out and I'm left with 1. That was a way you could do this problem. In this section, you're going to find that there's usually a lot of different ways you can go about it. So let me show you a different way. One of our kind of old standbys is, well, let's just change everything in terms of sine and cosine, because all trig functions can be written in terms of sine and cosine. For instance, we know that cotangent is cosine of x over sine of x, and we know that tangent is sine of x over cosine of x. Well, then I could look at this and say, well, my sines, I have a sine on top and another sine on the bottom, so those cancel each other out. For my cosines, I have a cosine on the bottom, a cosine on top. They cancel each other out. Well, when everything cancels each other out, I'm dividing everything by itself, I end up with 1. So either way works. A third method, I could have, instead of changing them all to tangent, I could have changed tangent to 1 over cotangent. Still would have worked the same way. Let's look at number 10. Number 10 says cotangent of u, and my board's not writing well right now, sine u. There we go. Well, cotangent of u and c. Once I see a sine and it's something not cosine or sine, I'm usually just going to go ahead and say, okay, well, I want to change them to sine and cosine. So I'm going to change cotangent to cosine of u, sine of u, and this one's going to stay sine of u. Well, I could put sine of u over 1 if I wanted to. I don't really have to, but maybe that helps you see better that I have a sine on top and a sine on the bottom. So those two cancel out, and I'm going to end up with cosine of u, and I could put over 1 or just leave it cosine u. Number 11. I have 1 minus cosine squared theta over sine theta. Now this one is where I'm going to use a Pythagorean identity, but it's not going to look just like the Pythagoreans we saw. For instance, we saw that the Pythagorean identity was sine squared theta plus cosine squared theta equals 1. Well, I can move terms over, just like following my algebra rules, so I could subtract cosine squared theta from both sides. If I do that, I get sine squared theta equals 1 minus cosine squared theta. Well, this right here is exactly what I have right there. So I can replace that with sine squared theta. So I'm going to replace the top with sine squared theta over sine theta. Well, remember that sine squared theta is just sine theta times sine theta. That's what it means to square something. So, one on top, one on the bottom, they cancel out. I still have one sine left on top, so my answer is just sine theta. If I would have had sine squared on the bottom and just sine on the top, my final answer would be 1 over sine theta. Alright, so this one always scares students when they first see it, but this one's really not that bad. It uses the fact that cosine squared theta plus sine squared theta equals 1. Well, I have a sine squared theta plus a cosine squared theta. Now there's a tangent in the middle of it, but we can just say, well, just a sine squared and a cosine squared would together equal 1. So I can replace this top part with, well, I still have the tangent squared u, but that sine squared and that cosine squared combine to make 1. So I end up with tangent squared plus 1. Well, let's think about this. I have to go back a couple slides just to remind ourselves. But tangent squared plus 1, or 1 plus tangent squared, that's one of my identities. And it's the same thing as secant squared. So come back over here. I'm going to replace the top with secant squared u. And then this one now looks just like the last problem when I have a squared on top and just a secant on the bottom. One of them cancels out, and I'm left with just secant of u. And that's probably all I have time for, because I'm going to have a class coming in just a second. I'll try to get some videos for some of the rest of these later.